can pick 40 bushels of apples in 6 hours, and Cody can pick the same amount in 8 hours. What if they work together, how long would it take them? Okay? So, what we're going to do, first of all, we know that Shanice can do it in how long? 6 hours, right? And Cody can pick them in how many hours? 8 hours. And we are looking for how long it takes them to do it to pick the apples together. So, what we're going to do is find out the rate of what they're picking in 1 hour. So we're going to ignore the 40 because we're just finding out how much time it takes them to pick 40. So we don't have to worry about that. So the rate for 1 hour for this one is 1 over 6, right? She can pick a sixth of them in 1 hour.
Oh, yeah.
Okay, same with Cody. He can pick an eighth of them in 1 hour, right? So I'm going to add these together to find out my total time that it takes them, because I know they can take one of the time together in 1 hour. Okay, so this is how you set it up. What is my common denominator in this case? Yep, or the other way you could say this is I'm going to take a 6, an 8, and a t, right? I'm going to multiply it all by that. So if I take the first one times a 6, an 8, and a t, do the same thing for the second, a 6, an 8, and a t, and the same thing for the last. What can I cancel out of the first one? 6. So I'm left with 8t. How about the second one? An 8. I'm left with 6t. And the last one, the t's cancel, so what's 6 times 8? 48. Now we can solve for t. 14t equals 48, and then what? Divide by 14. So t in this case would be 3.43 hours is how long it would take them to work on it together. Number 7 says it takes Alberto 10.5 hours to mop a warehouse, and Molly can mop the same warehouse in 8.7 hours. How long would it take them if they worked together? So it's the same process. So Alberto, if I did it, he did this in 1 hour. What's his rate? 1 over 10.5. And Molly, 1.87 over 8.7 over equals 1 over t. So my greatest common factor, not my greatest common factor, my common denominator will be 10.5 times 8.7 times t. Okay? So I'm going to multiply each of these by that. Why do they use t? Because we don't know what t is. We need.
No, like he looks so much like a addition symbol. It's never really.
Oh, that's why I always put like a little loopy. Huh?
Does the mean equal the same thing?
Yeah. You're trying to find out. Oh, no, you can't. I don't think the mean works. No, if you add them together and divide by 2, that doesn't work.
It should work though.
I don't think it does. Try it. See what happens.
Won't the mean be able to add time takes over working together?
Not in this case. Okay, so what can I cancel out here? Those ones, so I'm left with 8.7t, right? Plus this one cancels here, so I'm left with 10.5t. And then equals, yeah, what are those?
91.3.
Okay, 91.35. So if I add these together, 10.5 plus 8.7, 19.2t equals 91.35. Then divide. Okay, so t equals 4.76 hours, and that's how long it would take them to work together. Okay? So now if you were to do the average like you were saying, yeah, you get 10.5 plus 8.7 divided by 2. That equals
And
9.6.
divide that by 2 again.
And then divided by 2 again. But how would you know to do that?
Because, I don't know.
So you really do have to set it up this way. It's not the mean of the two of them. Okay? Let's look at 13. It says, working alone, Jimmy can mop a warehouse in 12 hours. One day his friend Amanda helped him, and it only took 5.45 hours. How long would it take Amanda to do it alone? So the only difference between this one and the other two is that they gave you the total already, and you're finding an individual. Okay? So let's go to a new page. Jimmy can mop the warehouse in 12 hours, so I'm going to put 1 over 12. We are trying to find out how long it takes Amanda. We don't know, so I'm going to put 1 over A for Amanda. And the total that it takes them to do it together, to mop the warehouse together, is 5.45. Okay? So our common denominator in this case will be 12 times 5.45 times t. Oh, A. Sorry, it should be A. Sorry, I'm so used to using t's, I forget. A. So let's multiply each of these by that. Amanda. Okay, so let's cross out what we have in common. We have a 12 here we can get rid of. We have an A here we can get rid of. And we have a 545 we can get rid of. So we're left with 5.45A equals 12 times 5.45, which is 65.4. Oops. It shouldn't be equals. It should be plus. 65.4. It's a decimal point there. Equals 12A. Yep, you're going to subtract. I would take the 5.45 from both sides. That way we just have a positive A. You could do it the other way too. Okay? And when we do that, we have 65.4 equals 6.55A. Now what? Yep, divided by 6.55. When you do that, you get an A of about 9.98. So it takes Amanda close to 10 hours to mop the warehouse, right?
Would you take 10?
Yeah, if you rounded it up, I would. Okay? So these ones are really, I mean, they look wicked because they're word problems. Nobody likes word problems. But they're not hard, okay? It's really the other worksheet that's hard, okay? So you guys here's strategy for you. Spend as much time as you can tonight on the rational equation ones. Okay? Then tomorrow, when you guys get together, you can compare notes. If you get stuck on something, you guys can work together to get the answer. Okay? No, Fridays are big tests.
Oh,
So Friday's test is over everything we had on the quiz, and then today's lecture.
No more?
There won't be, because I probably won't be here tomorrow. But be smart about it. You guys took that quiz, you knew how hard it was. Be smart about it. Do the rational equations tonight for your own good, so you'll be ready, okay? Yeah.